Hello everyone, hope you all are doing well. So today we are going to do the next question of our agriculture optional answer writing practice series. जो हमारी एग्रीकल्चर ऑप्शनल आंसर राइटिंग प्रैक्टिस सीरीज चल रही है उसका नेक्स्ट क्वेश्चन को आज हम लोग करने वाले हैं. एंड टुडेस क्वेश्चन इज explain the biosynthesis of gibberellins. We have to explain the biosynthesis of gibberellins. Secondly, also list the role of gibberellins in plants. What are its role in plants? With suitable examples, write its commercial usage in agriculture. And what are the commercial usage of gibberellins in agriculture? So the question is divided into three subtypes, that is three subparts. That is biosynthesis of gibberellins, role of gibberellins in plants, and commercial usage of gibberellins in agriculture. So this question was asked in IFOS examination, that is Indian Forest Services examination conducted by UPSC, that is in the year 2023. So this question was asked in IFOS examination, that is agriculture optional paper of IFOS examination of 2023. So this becomes important for us. ये हमारे लिए important हो जाता है. Let's see how we approach this answer. और बात करें अगर गिबरेलिन्स की तो previously it has been asked several times. All the PGRs have been asked in previous examinations, previous agriculture optional papers in several times. So you need to know all the PGRs, their applications, their role. That is very important. So please prepare it nicely. All the plant growth regulators, or you can say plant growth hormones. And I have taught these things in my static videos. When you go to the playlist section, you will find two playlists, that is agriculture optional paper 1 and agriculture optional paper 2. You can refer them if you want to know about all the plant growth hormones or regulators in details. So now let's move to the answer. So first of all, you should know what गिबरेलिन्स are. गिबरेलिन्स के बारे में एक basic information you need to know, that we all know that it is a plant growth hormone, or you can say plant growth regulator, and it was discovered in Japan. Discovered in fullish seedling disease of rice. Fullish seedling disease of rice. So in rice there is a disease named fullish seedling disease. Through that disease we are able to discover गिबरेलिन्स. There was a Japanese scientist who discovered it. So we will not go into detail here. आप चाहो तो इंट्रोडक्शन में ये चीज लिख सकते हैं. You can introduce your answer by mentioning these two things, that is that गिबरेलिन्स were discovered in fullish seedling disease of rice, and we all know that it is a plant growth hormone, or you can say plant growth regulator. So you can introduce your answer by writing this. Now let's move to the body of the question, that is first part, that is biosynthesis of गिबरेलिन्स. So this is the structure, or you can say diagram showing the biosynthesis of गिबरेलिन्स. So I will let you know how to approach this biosynthesis. Actually biosynthesis of गिबरेलिन्स have been divided into three steps. Step 1, step 2, and step 3. So the first stage, or you can say first step, takes place in plastid. Second stage takes place in endoplasmic reticulum, and third stage or step you can say takes place in cytosol. So what happens in the first stage? Trans-geranyl diphosphate gets converted into ENT chlorine. जो हमारे ट्रांस-geranyl डायफॉस्फेट है वो पहले ENT कोपेलिस डायफॉस्फेट में कन्वर्ट होता है, उसके बाद क्लोरीन में कन्वर्ट हो जाता है. आफ्टर दैट, आफ्टर गेटिंग कन्वर्टेड फ्रॉम ट्रांस-geranyl डायफॉस्फेट टू क्लोरीन, इट गेट्स ट्रांसफर्ड इनटू स्टेज 2. ये स्टेज 2 में चला जाता है, वेयर इट स्टार्ट्स एज कैरोनोइक एसिड, दैट इज कैरोनोइक एसिड से स्टार्ट होता है, एंड देन गेट्स ट्रांसफर्ड इनटू एंड देन कन्वर्टेड इनटू 2 subunits of गिबरेलिन्स, or you can say 2 subparts of गिबरेलिन्स, that is GA12 and GA53. It gets converted into GA12 and GA53. If you see the detailed steps of part 2, that which takes place in endoplasmic reticulum, you will see that this, let me change the color first, this caronic acid that gets converted into hydroxycaronic acid, then gets converted into GA12 aldehyde, and that's converted into GA12 and GA53. So that is gibberellic acid 12 and gibberellic acid 53. These are two types of subtypes of gibberellins. So after this conversion, so this takes place in second stage. Then first stage, what you say, geraphiline gets converted into choline. In second stage, caronic acids in the end gets converted into Ga12 and Ga53. अगर आपको middle, if you remember the middle parts, middle stages, you can write it. If you do not remember, just explain briefly that it gets converted into caronic acid to Ga12 and Ga53 in the second stage of biosynthesis, which takes place in endoplasmic reticulum. The third stage, which takes place in cytosol, this Ga12 and Ga53, after breaking into several pi units, divided into Ga4, Ga1, Ga3, Ga6, Ga7, ठीक है, Ga1, 3, 4, 7, 6 इसमें ये convert हो जाते हैं, and this takes place in cytosol. This is the third unit. It gets converted into first Ga15, then Ga24, then gets converted into Ga9, which breaks into Ga4 and Ga7. So like that, Ga53 gets converted into Ga44, 19, 20, then Ga1, and then Ga20 gets converted into Ga5, which breaks into Ga3 and Ga6. So this is the biosynthesis of gibberellins, which takes place in 3 stages and in 3 different places. That is first plastid, where geranyl diphosphate gets converted into choline. Then endoplasmic reticulum, where caronic acid gets converted into Ga12 and Ga53, and then cytosol, where we obtain the results, that is Ga4, Ga7, Ga1, Ga3 and Ga6. So this is the process of biosynthesis of gibberellin. I know it is a kind of difficult one, but you can remember it. We have got no choice, we have to remember it. And if you are able to remember this diagram, if you are able to make a simple diagram there, it will enhance your answer. So that is how you can write the biosynthesis of gibberellins. So I hope you are able to understand this. Now let's move to the next part of the question, that is role of gibberellin in plants. What are the role of gibberellin in plants? There are several roles. We will discuss the important ones. It induces maleness, it promotes growth of dwarf plant, it promotes seed germination, it is used for breaking the dormancy, helps in breaking dormancy. Helps in breaking both the dormancy, both seed dormancy also and bud dormancy also. So it helps in breaking seed and bud dormancy. Moving on, it delays senescence of fruits. Delays senescence of fruits. It promotes stem elongation. It accelerates flowering in long day plants. In long day plants. It intensifies transpiration, photosynthesis, respiration, photosynthesis, respiration, etc. So these are some of the most common role of gibberellins in plants. So I hope you are able to understand it. That it induces maleness, promotes growth, promotes seed germination, helps in breaking dormancy, delays senescence of fruits, promotes stem elongation. You can simply see it in sugarcane. To increase the growth content, it increases the stem elongation, elongates the internodes of sugarcane, so that the sugar content of sugar can increase in this part. So it is helpful there. It accelerates flowering in long day plant, intensifies transpiration, photosynthesis, respiration, etc. So these are the common role of gibberellins which we are able to see in plants. There are many other roles, but these are the important ones which I have mentioned here. You can also add another roles which you want to add in your answers, but whichever new points you add in your answers, please let us know by commenting. Comment करके हमें बताएं, so that we get to know that you are going in the right direction or not. So this is about physiological role of gibberellins. Now moving to the next part, that is practical uses of gibberellins in agriculture, or you can say commercial uses. What in question, it is mentioned in question, that is commercial usage. So we will write here commercial usage of gibberellins in agriculture. So first of all, it is very helpful in bolting and flowering. Very much helpful in bolting and flowering, and you can easily see it, for example, in rudbeckia. Rudbeckia. It is a common example, rudbeckia. I am just stripping rudbeckia species. In rudbeckia species, you can see that in Hysoscamus niger, you can see it. Hysoscamus niger. You can see that bolting and flowering there. So it is very helpful in bolting and flowering. It is very helpful for elongation of internode. As we have discussed in many various plants, it is very much helpful in elongation in internode. Thirdly, it is very much helpful in parthenocarpy, such as in fruits, such as in tomatoes, grapes. So it helps their parthenocarpy, that is seedless fruit or seedless vegetable, whatever you want to say, that enhances those fruits, those commercial value of those fruits. So parthenocarpy is, it is very helpful there. It is very helpful in malting of barley. Malting of barley. But it does here, it increases alpha amylase content, which makes malting easier. So it is very much helpful there. It is very much helpful in increasing the high sugar yield. Right? Sugar yield, as I have said in sugar cane. What happens here? It enhances the growth of internodes, as I have written here, elongation of internodes. Sugar cane, which I have explained earlier also. What happens here? It enhances the elongation of internodes. These internodes get elongated, and what happens? The sugar content which present in these internodes increases, which can be seen in sugar cane. It also helps in breaking bud dormancy. Bud dormancy, as well as breaking seed dormancy, which you can easily see in crops such as potato, grapes, cherry, plums, apple, etc. So it is very much helpful there. It is very much helpful in fast growth of seedlings. GA3 is very much used here. GA3 helps in fast growth of seedlings. Also in breaking seed dormancy, GA3 is used. It is very much helpful in control of plant growth. Control of plant growth. For example, it helps in arresting apical growth of plant. Arresting apical growth of plant, which reduces the cost of pruning in later stages. When the plant grows so big, we need to prune it. But using gibberellins, commercial application of gibberellins can help in control of plant growth. That is, it arrests apical growth, and we don't need pruning. It helps in modification of sex expression. Modification of sex expression. That is, it can helpful in it is helpful in inducing or producing male or female flowers. That is, it modifies in sex expression. For example, here MH, Tiva is very much used. So these are some of the commercial applications of gibberellins, that is in bolting and flowering, elongation of internet, sugarcane. It also enhances sugar yield, parthenocarpy in tomatoes and grapes. It is very much helpful in malting of barley, enhances the malting of barley by increasing the content of alpha amylase. It helps in breaking bud dormancy and seed dormancy in different crops such as potato, grapes, cherries, etc. using gibberellic acid 3. It helps in fast growth of seedling using gibberellic acid 3. It controls plant growth by arresting apical growth, which helps in reducing the use and cost of pruning. It also helps in modification of sex expression. So these are some of the commercial applications of gibberellins, that is commercial uses. So I hope you are able to understand what is biosynthesis, what is its role in plants, and what are its commercial uses. So that is all for today. I hope you understand all the things. So please do like, please do share, and please do subscribe. लाइक करें, शेयर करें, सब्सक्राइब करें. It takes a lot of hard work to make such videos for you on regular basis. So if you like, share and subscribe, it motivates us to make more such videos for you on regular basis. So that is all for today. Have a nice day. Thank you.